How's it going, everyone? Welcome. Javier Gonzalez here. Right now, I got some issue with the light bulb in my house, so I already talked to a handyman to come over here and try to help me here. So, in the meantime, right? Here we are. Well, you can barely see me, but the TLDR of today's video is to now dive deep into the JavaScript and be able to understand now the fundamentals, the pillar of the JavaScript, so we can now not only from a theoretical but a practical approach, we can is when it comes to come up with some problems, we can solve them in the most time effective possible way. So, because of that, I want to dedicate time to take notes from this course made by Kyle Simpson. So he's a software engineer that now has written several books, in which I want to now understand the mindset, or based on his experience, what are the pillars of JavaScript, so we can now write effective code and we can become competent JavaScript developer. Why is that? Because if you ask a room full of C developers if any of them have ever read the spec, the vast majority will tell you yes. But if you have a full room of JavaScript developers, they barely know that, right? And it's our job to be competent, especially in your career. If this is the career path that you want to develop, it is only you and your responsibility to develop that skill set and become efficient in that. So not only for yourself but also for your future self. Now, because of that, all right, the pillar that Kyle Simpson mentioned, where it elaborates that there are now this basic. I am being quite redundant here, my bad. But again, these three pillars is in JavaScript is now the type system. Understand that and the philosophy around the type systems, the coercions, and then now the scope. All right, so block scope, function scope, block scope, and then now the objects. What he mentioned is that this is objects, but this is the objects orientated. So behind the scenes we have stuff like prototype oriented programming and stuff like that. So again, this is just to develop the notion and the soft skill as well as the practical. So when it comes to now understand this particular pillar, and anytime we find out there in the boonies some issue, we know where we need to look and we know what the language is doing. Because most of the time, people, when they saw stuff like this and they now don't know how that works, is because they don't understand the language, and therefore when something doesn't reason the way how it think they're supposed to, they think now that that JavaScript is a poorly designed language. So this is quite interesting. This is also part of my mindset that I have before, because JavaScript is so intuitive that it's supposed to work based on our mindsets, based on our thinking, and that's not what it is, man. And this is also, if you can extrapolate this to other realms, so for example, dating market, the job market, or in any market, the buyer and the sellers, they agree to exchange or trade something, and there are now rules that governs that, right? And it is up to you to say, hey, if you don't have the money to pay that, or if you don't have the resource to exchange that, so it won't happen. So the point of this is you need to understand now the dynamics of the tool that you're going to use, in our case with JavaScript, so you can now be more proficient and effective. Because it is your job and your job alone to hone into that specific niche, in our case JavaScript, and become a rock star, so you can and becoming so your offer can be and become a rock star, so you make your offer a rock solid when it comes to offering to any client, right? So far so good. When we look at this, especially in this specification, also something that we're gonna see along the way in our career, is the ability to read this number algorithm spec or format here, from, of course, the ECMAScript 262. So this is actually part of the specific spec from that expression. All right, I'm not going to dive deep into this, but the thing here is that it says he tried to convert that number, all right, into a string. Let me actually, what I want to do is to put that at test. So this, what it does is to, whatever is on the left side, on the right side, exactly, whatever is on the left side of the operator here, all right, what it's gonna do is to try to convert or coerce that value into a number. For example, it's something like this. You try to coerce that value into a number, all right? So let's say something like this. In fact, let's say something like this. So you have now a variable called x, which is 5. You have another variable called g, which is a, right? And then you have now a variable, or you do something like this, say console log 5 plus plus, right? And then you say now console log g plus plus. So what is the expected output here? I mean, is this one. So, well, it's I'm going to try to convert this number into a string, and I will try to convert the value that you have here, so the value that holds g, into a number, okay? And if it is, I'm going to convert it into a number, all right? And if it is, I'm going to add now that to so we can put it something like this to actually be more descriptive, okay? And then I'm going to add 1, but I'm going to return is the old value. So in this case, it's going to return now 5. And here, it's going to return now, if the type conversion could not be happen to number, right? We can also, let's go to navigate through that, the ECMAScript here, spec language is spec, and let's go to find that out, which is the plus plus operator, what? Asterisk operations, to unit, to number. Oh, to number is this one. As you remember, is here. You say to number. Let the old value be the to number. All right. And to number is say if an argument is a number, return the argument. If the argument is either a symbol or a big ink, throw a type error section. If an argument is undefined, or return exactly. If the argument is undefined, return not a numeric representation of a number. If the argument is either null or false, return is a positive 0. Interesting, right? If the argument is true, return 1. This is for historical purposes, I'm assuming here, right? So 0 is widely spread to be used as for emptiness or false value, and true for 1. If argument is a string, return string to number, right? Is this one? Return the string to number argument. So if you navigate to this, the string that we're receiving is a number, right? And they say, let the abstract operation string to number takes the argument string and returns a number. It performs the following step. Let the literal be parsed text into string numeric literal. If literal is a list of error, return not a number. So here it is telling you what it's going to return, or is return the string numeric value of literal. So in other words, this will return is now not a number, right? So it's going to return not a number. Not a number is the only type of value that is not equal to itself, which means is that undefined is equal to undefined, null to null, boolean to true to true. So for example, like this, let's say true is equal to itself. Yeah, it is. False is equal to itself, to the value itself. Yes, it is. But it's nan, or not a number, not a numeric representation, okay, is the only type of value that is not equal to itself. So here we're going to see how we can now fix that particular issue when it comes to check that, all right? And while doing that, the value that is going to return here is, after trying to attempt that, okay, return not a number, after trying to return that, if when it's trying to transform the string into a number, and if the literal is a list of errors, return not a number, right? So it couldn't do that. So the value here, it'll be now 5, and therefore is not a number. Unexpected token. Human errors. Human errors. Here we are. There you go. Right. So again, this might be silly, but when it comes to try to diagnose and identify any problem, any issue that you might encounter out there in the wild, especially as you are going to build a web application or some 3D animation, or some landing page animations, some SaaS applications, or you want to connect to a database and then pull data out of this. You want to process inputs at the server layer in an API. So all of these kind of nuances becomes very important. Very important. So and for example, if we want to now say using this, all right, it's going to do the same, but now it's going to return now the new value out of this. Okay, so you're going to return here 6, okay, and then is nan, or nan as a number, right? So far so good. And this was just the introduction to this, with this little example. So then we move on to what we really care about. And I think this is a very interesting here, because when there is a diversion between what your brain thinks it is and what the computer does, that's when the box enters the code. It is important again to understand how this stuff works. So, this is part of the course overview. I mentioned before the type, scope, and object intake. Good. So, because this course is now laid out into types, coercion, philosophy of coercion, equality, and static typings. Okay, this 5 pillar or these 5 modules from the third pillar, right? So we're also going to look at primitive types. So far we have looked at that. We're gonna make a quick recap of that. The abstract operations, coercions, equality, and TypeScript. Okay, but again, I prefer to have these 5 topics in my mind and in your mind, right? So when you talk about now the foundations of JavaScript, all right, we talk about is now the types. We also talk about the scope and the objects oriented, right? So far so good, because now with this, at least for the first pillar, the types, that's what we're going to look at this. So on the types, first in types we have now primitive type, abstract operations, coercions, and equality here. So far we look at the primitive. I am quite familiar with this. I'm going to over that. And then now objects, right? This is quite interesting. So in JavaScript, variables don't have types. Values does. Values do, right? So because of that, because values holds the values, kind of redundant. So here, well, we look at these particularly operators, the type of operators, the kind of emptiness, so the type of always return now and a string. All right, you can take a look also at that, whether it's on the NBN docs or directly by looking is at the ECMA script, right? The type of unity, as you can see here, that's right, and I love it. Part of the language expressions, and this is important to understand the difference between expression and a statement, where now an expression returns always a value. I don't think they actually tell you something like this. ECMAScript language expressions, but in any case, primary expressions, left side of the expression, unity, exponential operators, additive operator, bitwise, relational operators. Relational operators, exactly. Private infill, that's right. Equality operators. Bitwise, you're gonna talk about now equality and what actually equality means to. Binary, bitwise, conditional operators. And then you also have this one, assignment operators, right? This is also something kind of new to this assignment operator, another assignment operator, and this one, all right? Conditional operators, language statement, functions and classes, but we talk about here expressions, primary expressions, arrays, objects, left hand side. So what am I looking here? Good call. I'm trying to identify is this operator, right? Which seems to not be part of this. I don't believe it. Well, in any case, type of, type of, the type of operator. Here we are. So it's this one, right? So now it returns you now a very specific set of constant value, string values, right? And all of them return you as a string. So far so good. I want to take a look now at that. So for example, here is what I wanna check is this. Nullish coalition, which to me is quite interesting because, let me see if I say nullish coalition. Okay. That's interesting. That's very, very interesting. Okay. Yeah, it's quite interesting that they don't have that added to that nullish coalition. Logical nullish assignment. I know that this exists, but this one. Okay. All right. Okay, no problem. Anyway. Yeah, anyway. Okay. Okay, no problem. No problem. Good. Well, in any case, yeah, it's quite interesting that doesn't appear. It is not relevant for us. We look at the type of operator here and the kind of emptiness where you have now the undefined, the undeclared, and uninitialized. So undefined is something that you haven't created. Undeclared is something that you haven't created. Undefined is something that you create, but it doesn't have a type or a value type assigned to. And the uninitialized, which is something that happened on the for block scope variables like cons, right? Is that your so you never initialize with undefined. What happened, for example, here with undeclared? Undeclared, you never create that. So they throw you a reference error. With undefined, you create that, but there is no type assigned to. Usually when you use var, by default, it creates that with this type value of undefined. But here in block scope variables like lets and cons, especially with let, because you can define you can initialize, you can create a variable out of the thin air without assigning any value to it. Therefore, it means that you create this variable, but you didn't initialize this. So it never initialized with undefined. So because of that, you can never have access to that, or you can never touch that in any form, shape possible, and you're gonna get this particular error. So we went through talk about the primitive and the objects, also the primitive and the objects, the type of operator, and what are the set of values that it gave us, anytime we want to check the value of a variable, the kind of emptiness would say is like, hey, it is undefined or undefined or undefined. It is undeclared, uninitialized, or undefined, right? And then now the special values, for example, like not a number, okay, which is a representation, is a numeric representation of not a valid number, and is the only value that doesn't is not equal to itself. And here's how you can, for example, start to see some gotchas using now isNaN to check that out. So the TLDR of all of this is that use the inline is not a number method from the number instant. You know, TLDR of all of that. So we also look at the -0, the negative and the +0, okay, which help us to indicate now directions useful, for example, in games or trading apps. And I think that's very, very interesting here. This particular design too. And then we look now particularly exercise, where in this exercise we want to now is implement the object.is. You can think of this object.is as the triple equal, right? Object.is is like the triple equal, right? Polyfill of the object.is. So the idea here is that recognize this early return. So if you receive, for example, now a number that, if you receive now two values here, I want to check now if these two values actually are helpful to cover most of the common use case, but there's some scenarios, right, in which these special cases. So for example, like isNaN, positive and negative zeros, all right? So if we want to check now if this number is NaN, all right, all we have to do is to say, hey, if their values are not the same. So if both values that we're receiving, they are not the same, therefore this is not a number, right? Which is in our case here. And then we return now is not a number, okay? However, if one of them is -0, all right, we're gonna grab that, this -0, we're going to now divide that by, we're gonna check if that value is now, so we want to check if that value is actually a 0, okay? If this value is actually a 0 and is now divisible, or the value that we receive is divided by is a negative infinite value, it means that this is now a -0. And therefore we're going to return that, right? We're going to say, hey, if this -0 or -0 here, let's gonna return now the coercive type of this -0. If it's not a number, all right, it's gonna return true for that. Otherwise, it's going to now do the triple comparison here. So again, this is just to look at these two special cases in actions and how you can solve them. You might wonder, yeah, that's good, that's fair enough to go with, but what's next? No, what's next? Glad you asked. The fundamental objects. So these fundamental objects are known as the building objects or native objects, but we talk about here the fundamental object because this is part of the language. All right. So there are two things that needs to do. especially using the new keyword. So you're gonna use the new keyword for some of these built-in objects. So you have now objects, arrays, function, date, regular expressions, and error. Okay? Anytime you want to create now an object or these native objects, you do that. But you never use that for creating is some primitive objects. So for example, like strings or number or boolean, right? So for primitive object, you don't use that. But for any other, right? Even for math, because you for math, you can say new math object. Oh, even for math, because you can say the object here. You're gonna tell you that. Look at this. So math object. Oh, because math is not an object. Exactly, math is not a constructor. So therefore, math cannot be instantiated. Okay, that's interesting. So date. Look at how now this gives you is this representation, right? It gives you now this date object. All right, new date. It gives you now this new date object. So let's get into this. Let's move on. Coercion.
Here we described, and I mentioned a thing called an abstract operation. If you recall, I showed you the to number.
Let's get into this. Coercion. Come on.
Number.
Okay. Coercion.
And I said, so earlier we described
coercion. Right? You're gonna talk about now abstract operations. The abstract operations. Okay.
And I mentioned a thing called an abstract operation. If you recall, I showed you the to number, and I said that's an abstract operation. So let's talk about what those are, because they are the fundamental building block that makes up how we deal with type conversion. So you see here in the spec that we have these abstract operations which perform fundamentally the task of type conversion. In JavaScript, we refer to type conversion as coercion. Okay? So we perform fundamentally the task of type that makes up how we deal with type conversion.
Okay, that makes up how we deal with type coercion. Okay, you got my attention. I'm all ears. There you got it.
So you see here in the spec that we have these abstract operations which perform fundamentally the task of type conversion. In JavaScript,
and they are defined here to aid the specification, the spec of the semantic of the JavaScript language. Other more specialized abstract operations are defined throughout this specification.
Script, we were type convert the to number, and I said that's an abstract operation. So let's talk about what those are, because they are the fundamental building block that makes up how we deal with type conversion. So you see here in the spec that we have these abstract operations which perform fundamentally the task of type conversion.
It performed the fundamental task of task operation.
In JavaScript, we refer to type conversion as coercion. Okay? So when you think of conversion and coercion, you should really think of them as interchangeable, at least as far as JavaScript is concerned. The first abstract operation that we have is called toPrimitive. Now, obviously, if we don't have a primitive, we need to turn it into a primitive. So if we have something non-primitive, like one that we have,
But again, this is the abstract
what those
operations.
Okay. And I mentioned a thing called an abstract operation. If you recall, I showed you the to number, and I said that's an abstract operation. So let's talk about what those are, because they are the fundamental building block that makes up how we deal with type conversion. So you see here in the spec that we have these abstract operations which perform fundamentally the task of type conversion.
So these abstract operations, okay. So these abstract operations perform this type conversion. Okay, these operations are not part of the ECMAScript language, and they are defined here to solely to aid the specification of the semantic of ECMAScript language. So exactly, this is the kind of okay, these abstract operations, which are the basic building block of how do we deal with type conversion or type coercion. These abstract operations perform these type conversions.
In JavaScript, we refer to type conversion as coercion. Okay? So when you think of conversion and coercion, you should really think of them as interchangeable, at least as far as JavaScript is concerned. The first abstract operation that we have is called toPrimitive. Now, obviously, if we don't have a primitive, we need to turn it into a primitive. So if we have something non-primitive, like one of the object types, like an object, an array, a function, whatever, and we need to make it into a primitive, this is the abstract operation that's going to be involved in doing that. By the way, the abstract operations are not a thing the JavaScript engine, they're not like a function that could somehow be called. There may, in fact, be actual methods inside of a JavaScript engine or not. They're not like required to be actual things. But when we call them abstract, we mean they're a conceptual operation. So anytime you have something that is not a primitive and it needs to become a primitive, conceptually what we need to do is this set of algorithmic steps, and that's called toPrimitive, as if it were a function that could be invoked. Okay? So the toPrimitive abstract operation takes an optional type hint. So in other words, it says, if you have something that is not a primitive, tell me what you think you would like, what kind of type you would like it to be. If you're doing a numeric operation and it invokes toPrimitive, guess what hint it's going to send in? It's going to say, I would like to have a number. That doesn't guarantee you a number, by the way. It's just a hint to say, the place that I'm using it, I would like it to be a number. If you're doing something string-based, guess what hint it's going to send in? It's going to send in string. Those are basically the only two hints. It can say, I would like it to be a number, I would like it to be a string, or I'm not going to tell you at all, so just give me whatever primitive you can. Okay? Another thing you need to understand about the algorithms within JavaScript is that they are inherently recursive, which means that they define something, for example, to toPrimitive. If the return result from toPrimitive is not a primitive, if it's another non-primitive, like another object, then it's going to get invoked again, and it's going to keep getting invoked until we can get something that's an actual primitive, or in some cases get an error. Okay? So there's a lot of these sort of spec machinations that happen that are recursive. And when we look at coercive equality a bit later, you'll see this idea that it's sort of being reapplied over and over and over again until we get a full result. So toPrimitive, the way it works, essentially boiling down the algorithm, the way it works is that there are two methods that could be available on any non-primitive, any object, function, array, whatever. Any non-primitive, there are these two functions. And you've almost certainly seen these before, the value of function and the toString function. And this algorithm says, if you've told me that the hint is number, then I'm going to first try to invoke the value of, if it's there, and see what it gives me. And if it gives me a primitive, then we're done. If it doesn't give me a primitive, or it doesn't exist, then we try the toString. And we either get a primitive or not. And if we try both of those, and we don't get a primitive, generally that's going to end up resulting in an error. Okay? That's if the hint was number. If the hint was string, they just reverse the order that they consult them in, but they still essentially consult both of them. So if the hint is string, we would ask for that object, that non-primitive's toString method, and if it has it, use what it returns, and if it gives us legitimately a primitive, like a string, which it should, then we'll just use that, and then we'll try value of. Okay? So just keep in mind, if you're going to use something that is not a primitive in some place that definitely needs primitives, like math or concatenation, in your mind, you should realize it is going to end up coercing it through this toPrimitive algorithm, and it's going to end up either invoking the value of
So this primitive is going to attempt to convert to coerce the value of some expression, okay, the value of some expression into a primitive, okay, and the process to do that is by passing a hint. Again, this is something that JavaScript is doing. This is something that JavaScript is doing, not us. Okay. And the process to do that is by passing a hint, all right? And if this is a string, it's going to consult these two operations to string n value of, and if that get you a value, okay, and if that gives you a value or a primitive value, if that gives you a value, therefore it will return the primitive value. Okay, therefore it will return the primitive value, whether it's a string or a number. And the same is for number, but with the reverse order. You're gonna say, hey, I'm gonna check if this is a value of. If it's not, let me check if this is a string. All right. Until it throws an error.
Or the toString. We'll see examples of the usage of those in a little bit. So let's talk then about the next.
So now we know about this abstract operations, which is just a fancy way to say this is kind of the basic building block of converting is the type of the value types. And then you have the two primitive. All right.
Next abstract operation, it's called toString. The toString abstract operation does what it sounds like. It's very descriptive of it on the label. It takes any value and gives us the representation of that value in string form. And almost every value that you can imagine has at least some kind of representation in string form. By the way, in the parentheses, I'm noting the actual spec sections as they exist currently in the version at this moment, which is ES 2018. They voted on the ES 2019 spec, and it'll come out a little bit later this year. Hopefully, most of these section numbers won't change, but those are for the ES 2018 spec. Okay, so the toString operation. Boiling down a bunch of details, let me just show you some examples of things and what they end up producing as a string representation. And for the most part, these are exactly what you'd expect. If you had a null value and you ended up doing that toString abstract operation in some way, you'd get quote null. Same thing with undefined, true, false, floating point numbers, even the zero. Things get a little strange when we look at the negative zero. Remember that. We already saw that it lies. The toString operation for negative zero lies and produces a quote zero. So that's one of the corner cases. And we'll talk more about corner cases in a bit. All right, so if we call toString on an object, remember, it's going to invoke the to primitive with the...
If we're going to invoke the to...
We'll talk more about corner cases in a bit. All right, so if we call toString on an object, remember, it's going to invoke the to primitive with the string hint.
Okay. Okay. So for example, an example, okay, we say, hey, is this one. So if we're going to invoke now a toString on an object is going to hold the two primitive with the hint string.
So what's that going to give us? Remember, that's going to end up calling toString first, and if it's present, and then it's going to use value of. That's the order that it does. So what's that going to look like on some particular object? Well, if it's an array, for example, string first, and if it's present, and then it's going to use value of. That's the order that it does. So what's that going to look like on some particular object? Well, if it's an array, for example, arrays have a default toString, which serializes a representation of the array. It's a bit of a strange serialization, in my opinion, because they're leaving off the brackets. So if you serialize an empty array, you get an empty string. I think that was a really dumb decision. I don't know why they left off the brackets, because it turns out there's a bunch of things that can serialize to strings, so how am I supposed to know whether it was, like an empty array? But nevertheless, this is how it works. The built-in toString on arrays leaves off the brackets. If we have an array with some contents in it, it'll show those contents unless they're null and undefined, and this is even weirder, the toString definition for this. I actually was just reading the spec the other day, and I was like, why on earth did they do this? Nulls and undefines, when they show up in arrays, just get left out. I mean, they're there presently. You can see there's a comma there. They're there presently in terms of position, but they're not represented as nulls and strings the way as nulls and undefines the way null and undefined when toString do. A bizarre, in my opinion, a bizarre inconsistency. Essentially, array toStringification is like, maybe you could use it in the dev console, but I would never use something like this in my program because of all these weird corner cases of its behavior.
And
like,
again, this is
maybe you could use it in the dev console, but I would never use something like this in my program because of all these weird corner cases of its behavior.
Yeah, especially when you try to do this.
What about on objects? I'm sure you've all seen the bracket object thing, which is like, what on earth is that? The default toString on the object.prototype is to do that whole bracket thing. And this, let me just rant for just a micro moment here. Why on earth did they leave off the square brackets for arrays and put the square brackets on objects? Somebody explain that to me. What on earth? Bonkers. Okay, but back to arrays and put the square brackets on objects. Somebody explain that to me. What on earth? Bonkers. Okay, but back to reality for a moment. They on earth. Bonkers. Okay, but
bonkers. Bollocks. Exactly. It's like that makes a lot of sense, especially when you do this kind of especially when you do this kind of operation. Oh, now things are starting to make a lot of sense. So, okay. So coercion here is talking about now the abstract operation, which is the basic building block of how do we make the conversions of types. How do we make the value conversion types? Okay? And it's going to tell you is the process of doing that. So it has now operations that allow you to do that, for example, to primitive, where it say, hey, this function, it takes now a hint, and therefore it's going to do is depend of the hint, whether this is a string or a number. If this is a number, it's going to check if that is actually a number with the toValue method. If it's not, it's go with the toString primitive, the abstract operation, to check whether it is. If this is now a string, it's gonna reverse that order. But this operation is gonna do that in a recursive way until there is an error there. So things start to make sense because when you now try to coerce an object, all right? When you pass now an object to the to primitive, and they pass now that as a string, and they have now a set of rules that coerce that. So for example, that's one of the things that we don't coerce. For example, array-like. You know, array-like array-like into a string to that. Exactly. Abstract operations to array type. So the question is this abstract operations are part of the language? That's a good question. That's a good question. That's a very good question. So if you say now, well, the type of is different because you're gonna tell you this is an object. But when you're trying to do this coercion, okay, the question is that is the toString exists? toString method? Okay, the toString as an array. All right. So for example, if you say a string or a string dot toString, all right, and then you want to do that for a function. Hey, I want to now is coerce this abstract type, coerce this. Now the spec has changed a little bit. You know, as you can see, the spec has changed a little bit. It's now giving you a object string. You know, and you say, for example, a new map. It gives you now a this one. So this might have changed. Okay, this of course has changed. And that's one of the reasons why he mentioned the spec 7.1 to that. Let's actually take a look at the spec here. We say, hey, spec with the ECMAScript, the current spec. I think this is on the draft, which means it's likely to be used. You can say ECMA spec 2025. All right. I think this is the actual. This is not a draft. This is the language spec. Please don't translate that. I don't know why you love to do this. Show me the original, please. Thank you. Please. Thank you. toString, all right. If the argument is a string, return the argument. If it is a symbol, undefined, null, true, and false. If this is a number, return a number toString. If this is a big int, return the big int toString. And this is an object. Assert the argument is an object. Okay, and let the prime value be toPrimitive, with the argument and the string initially, right? And assert if the prime value is not an object, and return toString if the prime value. And the other is toObject. It's an object. It's an object type, which contains the data and the accessor property. So assert the argument is an object. And then you get is this. The other is the toObject here. Alright, type error, undefined, null, false, number, big int. It doesn't mention anything of an object. Assert that an argument is an object. Let the print value be toPrimitive argument string, which is this numeric number, the number algorithm format here. This is exotic to here. Assert preferred type is number or in a string. Throw a type error present here. toPrimitive. It's gonna check for this. If the input is an object, then let the exotic to prime to be get methods input symbol to primitive. Okay. If the exotic prime is not undefined, then if preferred type is not present, then let the hint be default. If the preferred type is a string, then let the hint be string. Else preferred type is number, let the hint be number. and let the result be called the exotic to bring input to the hint. If the result is not an object, return the result. Throw a type error if it is an object. Interesting. This is too primitive, right? Throw a type error if this is an object. If preferred type is not present, let preferred type be number of that. And return the ordinary to primitive here. And then you have the toString here. toString is pointed out to 7.1.12, and now we are on the 17, right? And returns either normal completion containing a string or throw completion. It converts arguments to a value type string, and it performs the following step when called. Assert the argument is an object, and each instance of an object type also refers to simply as an object, representing collections to property, and representing collections of properties. Each property is either a data property or an accessor property. A data property and an accessor property. The property of an object are uniquely identified using the prototype, the property's keys. A property key is either a string or a symbol. All string and symbols, including the empty strings, are valid as property keys. So in other words, it has now this shape. So property key are used to access the property of the value. That's right. Exactly. Property key are used to access properties and their values. And there are two kinds of access properties: the get and set, corresponding to value retrieval and assignment. Value retrieval and assignment. Exactly. This is the fancy way to say that. To say, hey, I can have access to the data, and then I can read the data, and I can write the data, respectively. The properties accessible via get and set access include both owns property that are direct part of the objects and inherit property which are involved, which are provided by another associated object. So in any case, this is the shape of this object. But it's going to assert, it's going to check that. A step that begins with assert invariant condition of its algorithm. Such assertions are used to make explicit algorithm invariant that will otherwise be implicit. Such assertions and no additional semantics require enhanced check by implementation, and they're used to clarify algorithm. So assert, so make sure that the argument is an object, okay? And let the prime value to be the primitive argument string, where it's going to throw that into a primitive. Assert that the prime value is not an object. If this is an object, so return to string prime value. It's kind of recursive. If it cannot recursive here until it gives you now is or a type error, or an error, or some defined value, specific defined values. Okay.
Nulls and undefines, when they show up in arrays, undefined when square brackets on objects. Somebody explain that to me. What on earth? Bonkers. Okay, but back to reality for a moment. It does the square brackets, it does a lowercase object, and then it puts in this thing which is called the string tag. And it turns out you can actually override the string tag for any of your own custom objects using an ES6 symbol. You can It's called toString tag, and you could change it. So you could change it from saying capital O object there in that string to saying my favorite number, or whatever you want it to say. That's a meta-programming thing, but it is possible to do. So that capital O object there is the default string tag for all default objects, and then the toString method takes that string tag and wraps this other junk around it. If you override the toString method, you can completely control what you want the stringification of your object to look like. In this case, I'm making it return just the string x. I have used this, by the way. I have defined a toString method, but I've defined it as a getter, so that when it can be dynamically returned in the string tag. I've defined this in such a way so that on an object, and I don't do this all the time, but if I'm trying to understand what's in the contents of an object is not helpful to me. But you can override it and tell it to JSON stringify the object and print those results. And that is much nicer. So you can override a toString or the string tag to help you in the dev console. But again, this is not the sort of metaprogramming I would typically do much in my programs. So what about toNumber? This one's a bit more interesting because there's a lot more corner cases involved. Anytime we need to do something numeric and we don't have a number, we're going to invoke the toNumber abstract operation. Number, this one's a bit more interesting.
Okay, and this is what happened to the toString. And when you look at this, it's because now JavaScript is doing this abstract operation. It's trying to coerce or to convert that object into this object or into a string. And the other is toNumber. All right. The toNumber. Okay. The toNumber. Okay. The toNumber. Chill.
Because there's a lot more corner cases involved. Anytime we need to do something numeric and we don't have a number, we're going to invoke the toNumber abstract operation. So what are some examples of those? Some of them are well-formed, some of them are strange. Empty string, I think, don't have a number. We're going to invoke the toNumber abstract operation. Exactly. So what about toNumber? This one's a bit more interesting because there's a lot more corner cases involved.
Okay. So this one is much more interesting because it involves more corner cases. All right. It involves more corner cases. Okay.
Anytime we need to do something numeric and we don't have a number, we're going to invoke the toNumber abstract operation. So this one's a bit more interesting because there's a lot more corner cases involved. Anytime we need to do something numeric and we don't have a number, we're going to invoke the toNumber abstract operation. So what are some examples of those? Some of them are well-formed, some of them. Anytime we need to do something numeric and we don't have a number.
Okay. So anytime we need to do something numerical and we don't have a number, it's gonna call the toNumber operation. It's gonna invoke the toNumber operation. It's going to invoke the toNumber operation. Okay.
We're going to invoke the toNumber abstract operation. So what are some examples of those? Some of them are well-formed, some of them are strange. Empty string, I think, is the one that drives me the most bonkers. Empty string, when numericified, or whatever the right word would be for that, becomes 0. Now, as far as I'm concerned, empty string is the way that you say, I have no values in a string. It's the absence of any string value within that type. There's no other representation of the absence of values within the string type other than an empty string, as far as I can tell. So if it's the absence of value, why on earth does it, when it becomes a number, become an actual number like the number 0, instead of the number that already exists in the language that represents we don't have a valid number, which would have been name? I'm ranting on this particular point because it turns out we're going to see that's the root of all evil in JavaScript. But most of the rest of these are all very sensible. If you had the string 0, it becomes 0. If you had the string -0, here's a surprise, it actually becomes -0. Very cool. It strips off any leading white space and leading trailing white space and leading zero, so we just get 9. It handles floating points well. Some weirdness with the trailing and leading dots, but those are syntactically valid. It even handles others bases, like in this case, hexadecimal. So the numerification, I don't know what that word should be, of a string value is fairly sensible with a couple of weird corner cases. What about dealing with the numerification of falses or trues or nulls or undefineds? What about those other primitives? Well, false becomes 0, true becomes 1. And at the outset, you might think, oh, well, that makes complete sense. Historically, we've always thought of false as being 0 and true as being 1, from a bitwise perspective. I'm going to put my foot down and say that was a terrible idea. That false and true went as being 1, from a bitwise perspective.
Exactly.
You might think, oh, well, that makes complete sense.
So from a
Historically,
bitwise perspective, interesting. I want to know, I want to take a look at this. Okay. I want to take, oh my God. I want to take a look at this. Because exactly, false and true values, from a bitwise perspective, what in the F is this bitwise? What does it mean bitwise in Spanish? Bit a bit, bitwise. Bitwise. Let me ask Claude on how it translates that. How would you translate that? Because that'll be. I would like to know your thinking here. Yeah, this is actually the basics of the language that we must know. Oh my God. Yeah, it is, man. That we must definitely know. Oh. What's going on? Hello? You there? Hey, are you there? Hello? Come on, Glo. What's going on? Okay. Exactly. So anytime we talk about bitwise, is from Spanish is a nivel. De la perspectiva, a nivel. All right. A nivel de bits. Good. So bitwise or a nivel de bits is that. Okay. So from a bit, I love it. A nivel, exactly, a nivel. From a true perspective, false and true from a bit perspective makes sense to be 1 or 0, right? 1 y 0 o los valores positivos y negativos tienen mucho sentido desde una perspectiva a nivel de bit, de lo que representan. Okay, exactly.
Of false as being 0 and true as being 1, from a bitwise perspective. I'm going to put my foot down and say that was a terrible idea. That false and true, when represented as numbers, should have represented as nan. And you'll see why a little bit later. But I don't like that decision, but I understand why within the context of greater programming, that's probably what most people would expect. Null becomes 0. Okay. But undefined becomes nan? What? Here they decided to finally use nan, but they didn't use it with null? Somebody explain that one to me. Null should have been nan, just like undefined should have been nan. Okay. So when we use toNumber on a non-primitive, that's not a string or not an undefined or a Boolean or whatever, when we use it on an object, remember it invokes the toPrimitive with the number hint. And if you recall, that consults first the value of, and then it consults the toString.
Exactly.
So what does that look like? Well, for any array or object by default, meaning you have not overridden these, the value of method essentially just returns itself. It essentially does this return this, which has the effect of just ignoring the value of and deferring to toString. So it doesn't even matter that the hint was number, it just goes directly to the toString. You can think of the numberification of an object as essentially the stringification of it, is that it's going to end up producing whatever toString or value of produces. That's a perplexing choice, but it's the choice nonetheless, is that it's going to actually produce a primitive string. So then in your various operations where you were expecting a primitive but you wanted a primitive number, there's actually a primitive string there. And then further coercions.
There's a primitive string.
So we're going to end up deferring to the toString and whatever the toString returns. Remember how arrays toStringify themselves without any brackets. So again, we get an array with an empty string in it. When we toNumber it, it ends up as 0, which is nuts. And then the string with 0 in it becoming 0 makes a lot more sense. And -0 makes a lot more sense. Here's something bizarre. If the array has either null or undefined, it becomes 0. See if you're paying attention. Can anyone tell me why both of those become 0 here?
Not consistent with the rest.
Which is nuts. And then the string with 0 in it becoming 0 makes a lot more sense. And -0 makes a lot more sense. Here's something bizarre. If the array has either null or undefined, it becomes 0. See if you're paying attention. Can anyone tell me why both of those become 0 here?
Not consistent with the rest.
Actually, this is remarkably consistent with the other craziness we've already...
This is for consistency, but for the others, it's like...
Because they first become empty strings.
They first become empty strings, and then empty string...
Not consistent with the rest.
Actually, this is remarkably consistent with the other craziness we've already seen.
Because they first become empty strings.
They first become empty strings, and then empty string becomes 0. Remember, empty string is the root of all coercion evil, okay? Empty string becoming 0 is the root of all coercion evil, okay? Same thing with that bottom crazy nested array thing. It just becomes an empty string, which then just becomes 0, okay? All right, so...
This kind of operation, for example, like null and undefined, is because it converts into a string, and therefore into a 0.
Empty string in it, a lot more becomes 0 here.
Yeah, damn.
Here's that it ends up returns. It's the choice nonetheless. The string of essentially just, so what is that? It's in an object. Okay. So, and if you recall, that default, meaning you have first the value of, and then it consults the toString. So what does that look like? Well, for any array or object by default, meaning you have not overridden these, the value of method essentially just returns itself. It essentially does this return this, which has the effect of just ignoring the value of and deferring to toString. So it doesn't even matter that the hint was number, it just goes directly to the toString. You can think of the numberification of an object as essentially the stringification of it, is that it's going to end up producing whatever toString or value of produces. That's a perplexing choice, but it's the choice nonetheless, is that it's going to actually produce a primitive string. So then in your various operations where you were expecting a primitive but you wanted a primitive number, there's actually a primitive string there. And then further coercions will kick in. So we're going to end up deferring to the toString and whatever the toString returns. Remember how arrays toStringify themselves without any brackets. So again, we get an array with an empty string in it. When we toNumber it, it ends up as 0.
Yeah, wait a single moment. Wait a single moment. And we're back. All right.
Which is nuts. And then the string with 0 in it becoming 0 makes a lot more sense. And -0 makes a lot more sense. Here's something bizarre. If the array has either null or undefined, it becomes 0. See if you're paying attention. Can anyone tell me why both of those become 0 here?
Not consistent with the rest.
Actually, this is remarkably consistent with the other craziness we've already seen.
Because they first become empty strings.
They first become empty strings, and then empty string becomes 0. Remember, empty string is the root of all coercion evil, okay? Empty string becoming 0 is the root of all coercion evil. They first become empty strings, and then empty string becomes 0. Remember, empty string is the root of all coercion evil, okay? Empty string becoming 0 is the root of all coercion evil, okay? Same thing with that bottom crazy nested array thing. It just becomes an empty string, which then just becomes 0, okay? All right, so if you have an object, its toString returns the object. And remember what a stringification of an object by default is that square bracket object thing, which is definitely not a representation of a number. So we get nan. That's actually reasonable. It's dumb, but it's reasonable. If you override the value of for some object, you can return whatever thing you want. In this case, you could return 3, and that's the numberification for it. And finally, let's look at the two Boolean abstract operation. And by the way, these four are what we're looking at: two primitive, two string, two number, and two Boolean. There are other abstract operations that they refer to and use, so read those in the spec if you're curious, but these are the major ones you're going to run into. So two Boolean, section 7.1.2 in the current spec. Anytime you have any value that is not a Boolean, and it's used in a place that needs a Boolean, this operation occurs. Exactly the same as the other ones, okay? This operation is less algorithmic and more lookup. There's not really anything to do other than to say, is the value what we call falsy or not? That's really the only question here. So there's essentially a lookup table, literally in the spec, that says, is the value one of these things? If so, return false, meaning the false value is what came back from two Boolean, and otherwise just return true. So it defines a very specific and short, limited list of what we call falsy values. That is, values that will return false when coerced to a Boolean, in any of the various ways that you can coerce to a Boolean. These are the falsy values: the empty string, either of the zeros, the null, the nan, the false, and the undefined. Those are our falsy values. If it's not on that list, it is always truthy. Okay? If it's not on the list, it is truthy. So some examples of things on that list is infinitely long, but some examples would be a string, a number, an object, an array, true, function. Those are all truthy values. Let's see if you're paying attention. What would happen if you tried to two Boolean an empty array? Would it be truthy or would it be? Let's see if you're paying attention. What would happen if you tried to two Boolean an empty array? Would it be truthy or would it be falsy? So pay very close attention to how I describe the two Boolean. It does not invoke the two primitive algorithm, or the two number, or the two string, or anything. It just does a lookup. So is the empty array on the falsy list?
No, it's not. It's true.
So what must it return?
Truthy.
Okay? That's a key thing to keep in your mind. When you're doing two Booleans, when that's what's happening, there's no other coercion stuff happening. It's just a straight lookup. Is it there or is it not? You can't override it with a value of or a two-string or anything. It's just, is it on the list or is it not? Okay? So that's how we get our falsy and truthy values. Essentially, memorize the falsy list and then always ask, is the value on that list? If so, falsy, otherwise it must be truthy. With those as our foundation, those abstract operations as our foundation, it is now time for us to switch gears and really tackle this topic of coercion. And by the way, as I said at the outset, this is going to require, for you to get anything out of what I'm about to say over this next bit, it's going to require you to have an open mind because you have been so programmed to believe that this is an evil, buggy, horrible part of JavaScript that you should avoid, that it's hard to see any value or merit out of this discussion. But I make it such a point, I put it at the very top of this course, because I think it's one of the most undervalued and underlooked at things in all of JavaScript. So, to start off with, I know most of you follow that behavior and that advice that says, oh, no, I just avoid coercions. I just use the triple equals. I don't deal with types. Not so much. Let's look at some examples where you're already doing coercion, whether you realize it or not. Any of you used the ES6 as of a few years ago, the template literal strings? I certainly use these all over the place. This is one of those slow burns, because when it first came out, I didn't really care about this feature, and now I love this feature. Might be on my top 3 favorite features. I use it all the time, especially in my console.log statements. I just use it everywhere. And I love template strings. Any of you drop in values into those expressions that aren't already strings? Probably, like all of you. Guess what's happening there? That number is getting coerced to a string. Implicitly. Ooh, evil. You're already doing coercion, all of you. Guess what's happening there? That number is getting coerced to a string. Implicitly. Ooh, evil. You're already doing coercion, all of you, period. No matter what Doug Crockford said, you're doing coercion. You're relying upon coercion in your programs. And that's not a bad thing. That's a perfectly great thing. But under the covers, you should have the mental model that what's happening here is I'm taking a string, message 1, and adding it to a number. Now, why does that end up happening here is
It's coercing that value. In taking that value and coercion to a string.
you're relying upon coercion in your programs. And that's not a bad thing. That's a perfectly great thing. But under the covers, you should have the mental model that what's happening here is I'm taking a string, message 1, and adding it to a number. Now, why does that end up producing a coercion? Well, it's actually invoking another little magical thing that programmers love to do, which is we've got operator overloading. The plus operator is normally thought of as doing numerical operations. But The spec says that if you use the plus operator with something that's a string, and here's an example that a lot of you have probably done, add an empty string to a thing to turn it into a number. Did you ever stop to wonder how that worked? Well, it's because the spec says that.
Well, the spec says is that depend of the type of this, which is in a string or a number. Exactly.
The plus operator, if either one of them is a string, notice that or there, if either one of them is a string, the plus operator prefers string concatenation. Which means, if only one of them is a string, guess what's going to happen to the other one? A two-string operation right there on 7.a. It's going to call a two-string abstract operation on it and turn it into a string with all of the weirdnesses and caveats thereof. When it's a well-formed number, like the number 16, not such a big deal. But there's lots of corner cases on numbers and lots of corner cases on other values. And you're just invoking these things happily and not worrying at all about the fact that you're using coercion. Now, I'm not here to tell you stop using coercion. I'm here to tell you you're using coercion, so wouldn't it make sense for you to learn it? That's why we dive into this, okay? So, you may say, well, listen, I don't like to do those like implicit coercions. I want to be super explicit about it. Okay, so here's some crazy ways that you can be explicit about it. I just learned this one the other day. I never even considered that you could throw a value into an array, just the one value into an array, and then call .join on it, and that actually ends up stringifying it. Even though it does no string concatenation at all, the spec for .join first turns it into a string. An array, and then call .join on it, and that actually ends up stringifying it. Even though it does no string concatenation at all, the spec for .join first turns it into a string. Don't do this. That's a terrible idea. But you could, if you want to be super explicit about it, you could say, listen, I'm only doing string concatenations here, so I'm going to be explicit about turning my number into a string. Here's some other ones that are maybe a little more well-formed. You might, for example, call the toString method. Okay, cool. The toString method, at least on the label, says what it's doing. It's going to turn a number into a string, so that's not too bad. There is a little weirdness here, which is, how are you calling a method on a primitive value? Primitive values don't have methods.
Mm-hmm.
So you're actually already still doing implicit coercion here, and we'll come back to that. If you don't want to do any implicit coercion at all, basically your only option is to use that fundamental object without a new keyword. String, and this is my preferred way of explicitly coercing that number to a string, the capital S string function is going to do that for you. So if you're one of those that says, hey, listen, all those implicit things, those are magical and weird and I don't want to do them, and you want to be explicit about it, there's an example of being explicit about it. I'm not so sure that that's a great idea in all cases, but that's at least a way of being explicit. All right. So string to number to string, all right. But what about the other way around? You're already doing that too. Because all of you are dealing with web applications, or at least most of you are dealing with web applications, which means you're dealing with user input from things like form elements, which means you're grabbing things as strings, and then you're just doing numeric stuff with them. When you throw that string value at the plus operation, like I'm doing here, guess what happens? Oops, we get a string concatenation. Instead of getting 17, we got the string 161. But okay, I'll go ahead and force it to be a number. Okay, there's two ways of forcing it to be a number. One, this operator, the plus operator here. The unary plus operator, if you looked in the spec for it, guess what it invokes? Which abstract operation would we expect that to invoke? The two-number abstract operation, okay? Just make it unary plus operator, if you looked in the spec for it, guess what it invokes? Which abstract operation? There's two ways of forcing it to be a number. One, this operator, the plus operator here. The unary plus operator, if you looked in the spec for it, guess what it invokes? Which abstract operation would we expect that to invoke?
The two number?
The two-number abstract operation, okay? Just making sure you're all awake, okay? It invokes the two-number operation. That's all it does. So here we're saying take that thing that's a string, or whatever it is, and turn it into a number before we pass it in. If it's a well-formed numeric representation in string form, for example, you're going to end up with good results here like 17. If it's empty, guess what you're going to end up with? What's
Noun?
the empty string going to become? 0. May not be what you want, but it's going to happen. So here's another example. This kind of coercion happens all over the place. And my biggest frustration is that people don't deal with it and then just sort of slap a name badge on this as, oh, I don't have to worry about types and coercion. I'm good. This is where bugs come from, using tools that you don't understand how they work. Okay, so let me be more specific about it even than the plus operator, because that might look a little weird. You can use the fundamental number function. Okay? This is my preferred way. If I'm going to turn something into a number, I use the number function. We don't have a to number, so this is basically the most semantic way of telling the reader of your code that you're going to make a number out of something. If you use a minus operator, for example, if any of you get too sarcastic with me, I'm going to kick you out. If you use the minus of operator, that one's only defined for numbers. It's not overloaded for string. It doesn't make any sense to subtract one string from another. So that minus operator up there is going to do what?
A numeric?
Come on. To number. Okay? It's going to invoke that to number abstract operation. Operator up there is going to do what? Come on. To number. Okay? It's going to invoke that to number abstract operation. These are all things that are happening in your programs in various different ways. And I think it would be a good idea for us to call these things out and be a lot more aware of and cognizant of and intentional about them. Okay. Strings and numbers, they got all these weird things. But you know what I never do is I never mess around with coercions with my Booleans, right? Because I never write if statements.
That's the reason why I'm here, Emma. Because it all starts with a question, which is, what in the if is going to coerce that? Because if values, anytime that you put a value on an if statement, what is the value that is coerced that? You know? It is a Boolean, it is a number, it is a string, and how do you evaluate that into a Boolean?
Booleans in the if clause. Any of you use like checking to see if a string is non-empty to see whether it's truthy or not? Extremely common practice. Guess what that's called? Coercion. Okay? And guess what? All of the weird corner cases of coercion, Booleans, are in effect. Even with your little simple if statements, they're in effect. Matter of fact, I would say there are more corner cases with Booleans maybe than any other primitive type. All kinds of weirdnesses that we're going to get into here as we go. So that empty string, if student's input value is an empty string, that's going to be falsy, right? But what if that string has just a bunch of white space in it? Now it's going to be truthy, right? That's going to be falsy, right? Here as we go. So that empty string, if student's input value is an empty string, that's going to be falsy, right? But what if that string has just a bunch of white space in it? Now it's going to be truthy, right? It's not a valid string that you care about because it's got a bunch of white space in it, but all of a sudden it's going to be truthy. Corner cases even with our Booleans. Another favorite one, people love to use the numeric coercion of a number to either a 0 or a non-zero for a truth.
Let me actually check that out. You know, what is the expected value of a string? Oh, grab. Exactly. It have now a lookup list of any false value. Okay, if anything of them are, if any of those falsy values are not there, it becomes now a true. Holy. Question is, that might something that you want in your code? I hardly. I barely think. I don't think so. I definitely don't think so. No. I barely don't think so. No, not at all. Oh crap. Okay.
Truthy or falsy, right? So if my length is 0, then it becomes false, and if my length is anything non-zero, then it becomes true, because it's not one of the zeros. You'll have to rely upon that. Except what happens when it's nan? Okay? 0 or a non-zero for a truthy or falsy, right? So if my length is 0, then it becomes false, and if my length is anything non-zero, then it becomes true, because it's not one of the zeros. You'll have to rely upon that. Except what happens when it's nan? Okay? There's all kinds of corner cases in all of these coercions. So if you're in the habit of using some of these and not using others, I mean, I hate to call this out, but it's sort of hypocritical. to say, oh, I use this form of magic, but I don't like that form of magic. I don't think we should use the magic at all. I think we should learn it, use it, and then it's not magical at all. Once you learn it, you're doing something intentional, and you're communicating your intent to other people. That does not mean that implicitness is always bad. As a matter of fact, implicitness can be very useful. It just simply means we have to be very careful and intentional. So, you might say, well, I like to turn all of mine into explicit Booleans. So you might use that double negate up there on line 1. That's telling it become a Boolean. I don't have it on this slide, but you could also use the fundamental capital B Boolean. That's what I prefer to do. Just like string and number, I prefer to use capital B Boolean. But with numbers, it's better, instead of relying upon that numeric coercion, use something like greater than 0, if that's what you mean. Not only does it protect you from some of those corner cases, not all, but some. It protects you from some of those corner cases, but it's also more semantic. Because you're saying here, keep looping while the length is greater than 0, instead of keep looping while the length is truthy. What does that even mean? Okay? So don't be clever just to save a couple of characters. Be more explicit about it in the places where explicitness is more communicative. We already covered some of this. I jumped ahead in my slides, but the Boolean of an empty string is false, the Boolean of a non-empty string is true, and that's certainly going to be a gotcha.
Because he's doing this type coercion.
Okay. The Boolean tests for undefined and null, we know that both of those are on the falsy list. I like to treat null and undefined as indistinguishable values, wherever possible. So it's not always on the falsy list. I like to treat null and undefined as indistinguishable values, wherever possible. So it's not always possible to treat them as indistinguishable, but where possible, I like to do so. And coercion actually is very helpful for that. But with respect to Booleans, since we know that they're both falsy, if the test that we're asking for is, has this thing been set or not? Which we do often. Has this thing been set to an object, or is it still unset, right? For me, that's a perfectly reasonable implicit Boolean coercion. As a matter of fact, it's really the only implicit Boolean coercion that I'm okay with. I don't like to implicitly coerce empty string to false and non-empty string to true. I don't like to implicitly coerce numbers to true or false. But I am perfectly happy with either saying it's null or undefined, meaning it's unset and that's falsy, or it's been set to something like an object and then it's truthy. And I use that all over the place. So in my particular opinion, I think it's okay to use the implicit to Boolean coercion when we're specifically talking about either an object or a null undefined, that decision making. But the numbers and the strings, since they have so many corner cases, I don't think that that implicit coercion carries its own weight. I'm less trying to be prescriptive here about exactly how you should do it, and more trying to get you to think like JavaScript and make your own determinations for where do I draw these lines. I referenced a bit earlier a sort of magical behavior like accessing properties on primitive values. Remember, you access a length on a primitive string or some method on a primitive number, for example. So how does that work? How is it that we access the dot length of some string value here? This DOM element's value is always a string, so how do we access that dot length? Well, it turns out that's called boxing. It's a form of implicit coercion. It's not called out in the same way in the abstract operations, but I think it...
Well, that'll be all for this video. Take care. Bye-bye. And we're back. So this numeric representation, or these values here, okay? These values that anytime that you are trying to coerce or convert a value to another type, to another primitive, okay? JavaScript is gonna do this behind the scenes. And the reason of looking at this is anytime, in my case, but it's also for other cases, but anytime you want to check if a property exists, if the value of that property actually it is a number or a string, and then you want to coerce that into a Boolean, this is when things started to be quite weird for me because I don't understand that, right? So far we went through, look at what is this abstract operation is all about, which is a fancy way to say conceptual operations that happens in the language that converts the value of two different types, that converts the value here. Okay, so the abstract operation performs this type of conversion, and then you have now several abstract methods or abstract operations to do. One of them is the toPrimitive. All right, let me actually describe that. Abstract operation toPrimitive, which is now these operations that a language has now a hint to say if this is a string or a number, and if this is a number, it's going to first check that this is a number with this property called value of, and I want to check what value of is doing. Here you can say, hey, value of is now similar to, for example, math. All right, is a built-in object that allow us to check is that, right? You can say, hey, type error can convert undefined to object. Okay, because it only convert is numbers, right? It only convert is numbers. And this is interesting because value of is, we take a look now at the MDN docs, or even though here, value of, read event, they property value of, on the global, on the math, value of read event, but I think this is for another stuff. Abstract operations, value of read. If we take a look at MDN docs, value of, if we look at value of, but not from the date, object property, date property, value of, interesting. It's like all objects has this value of methods, right? Of object instance converted this value to an object. However, we have access to this value of. It received no, okay. Doesn't have any parameters, and it converts to an object. In order for value of to be useful during type conversion, it must return a primitive, because all primitive type has their own value of methods. Calling a primitive of value generally does invoke the object or prototype of value of. But JavaScript calls the value of methods to convert an object to a primitive. You rarely need to invoke the value of method yourself. JavaScript automatically invokes it when encountering an object where a primitive value is expected. This method is called in priority with the numeric conversion and primitive conversion. But string conversion called to string in priority. And to string is very likely to return a string value, even if the object or prototype to string based implementation. So value of is usually not called in this case. All objects that inherit from object prototype that is all expected null. So the thing here is that this value of, as you can see, are methods, primitive methods, okay, that from the toPrimitive, it's I'm going to depend on the hint I receive. I'm going to try to convert this into a number or a string. Okay, that's what this toPrimitive. And let me take a look now toPrimitive, because toPrimitive. Oh, there you got it. toPrimitive. All type coercion algorithm look up the symbol and objects. toPrimitive, and it pass now the hint. Right? So this is what this hint is all about. When you look at now toPrimitive, there you get it. This is an abstract operation. You're gonna pass the input and the preferred type, right? Exactly. The abstract operations to primitive takes arguments input, ECMAScript language value, and optional arguments, the preferred type. It takes any input value, all right? And as you define is this input value, this all of this primitive and all input values here. So null, boolean, string, symbol, numeric, object type, all right? And then now a hint, the preferred type, string or a number, and returns either a normal completion containing and an ECMAScript language value or throw completion, right? So it converts its input arguments to a non-object type. If an object is capable of converting to more than one primary type, it may be used to optional hint preferred type to favor that type, and it performs the following step when called. So the thing here is that behind the scenes, anytime that there are now type conversion, it say, hey, I'm gonna take this, I'm gonna take these two values, all right, and based on this, I'm going to try to convert them into a primitive, okay? Whether it's a number or a string. Hola, ¿qué tal?
Todo muy bien, ¿y tú?
Bien, bien.
Excelente. Yo bien te llamaba porque queremos practicar la entrevista que no se pudo dar el lunes. Ahí te mandé un correo con tu disponibilidad, pero no recibí mensaje, por eso te llamaba para que me puedas compartir tu disponibilidad para que podamos agendar esta reunión.
Listo.
Súper. ¿Qué día te queda mejor poder tenerla?
De lunes a viernes, de 7 de la mañana a 9 de la mañana, ¿me parece?
Perfecto. Déjame ver un ratito. Ahora te digo la disponibilidad. Monitorear. Ok. El viernes es el primer horario disponible. Solamente hay horarios para las 2 de la tarde, 7, 8. Te quedaría bien tener el curso al final de la tarde, como a las 7 u 8.
Bien, bien.
Perfecto. El viernes próximo, 13 de junio, 7 de la tarde, ¿te queda bien?
¿Una cita más cercana?
El viernes es el primer día disponible en tema de React.
Bueno, perfecto.
Está bien, perfecto. Entonces, 7 de la tarde está bien, ¿verdad? Porque el primer horario más central es 2 de la tarde, pero no es disponible.
No, eso no estoy disponible. A las 7.
Bien. Excelente, súper. Enseguida te va a llegar la nueva invitación y cualquier duda o consulta, bien, no dudes en contactarte.
Perfecto. Bueno, muchísimas
Que
gracias.
tengas un muy bonito día.
Hasta luego, chao, chao. All right. So this is what's going on. This is what happened here with this number and the string operation, the value of the string. So this is so if the operation, if the coercion is between any of this type, all right, it's gonna call it to primitive and say, hey, I'm going to pass now to the number. And then I'm gonna run is the value of, all right? If it is good, it means that this is a number. If it's not, I'm going to now pass through the string, to the toString. And the same is in the reverse order for the string. To string and then to value. However, what happened, you know, what happened when we evaluate now to string? Okay, because for what happened when we are evaluating is a value and coerce that into a string. So for primitive, it's like pretty much the same. Null, undefined, true, false. You know, this is actually it's very intuitive. This, unless it is minus 0, right? Unless it is minus zeros. But what happened when we want to coerce now an object into string? All right, it's gonna call it to primitive with a string identifier, aka it's gonna run is the to primitive to string, and then the value of. So if we want to, for example, convert or coerce to a string an object, and especially an array, again, this is part of the spec at that moment, you know, because this will work is for that particular version, you know, for that particular version that'll work. For that
So let's talk of that
for that
even
particular
weird
version,
materialism.
it'll work.
That's the order that it does. On and off 0. Remember, exact.
I
It's an
don't
array.
think he put the version of that. I think it does, exactly. It's here. This is from 7.1.12. That's what it's doing. When you try to coerce that into a string, if you want to check that out, you're going to say, hey, to string, and then I want to coerce this, right? Or this, or null. All right. So again, this is all to try to coerce this. But it turns out that now they have unified that. So if we take a look now at the toString, like this, especially for an object, to a string, especially into an object, what it's gonna call here is now the primitive, say to primitive, is gonna pass now into a string. If the input is an object, then let the XOR to prime get methods input symbol to primitive. If the XOR prime is not undefined, then do this. If the preferred type is not present, let the preferred type be number, and return the ordinary to primitive. The ordinary to primitive is that, and passes the string. If hing is a string, let method to string and then value of. If it's not, value of to string. For each element named on the methods, do let me method get. So again, it doesn't tell you is the table in which it converts that, or I'm not able to see that here, you know, I'm not able to see that here. Why this is important? Good question, good question. Why this is important? Why this is important? Well, because we want us to is try to coerce those here, try to coerce those values here into a string. So for example, if we say something like this, okay. So this toString object is always going to return that. So it's not useful. It's not useful. All right. So one way to check that is by doing something like this. So console log of this. I want to, for example, this to string, right? Which is an empty string. No, okay. This is an empty string. If I want to now coerce this, it coheres that to 1, 2, 3 as a string. That's right. If I want to do something like this, if I want to coerce now is this, say null or undefined, it now give you a comma, motherfucker. All right. And if you want to coerce now a it gives you now an empty string. You say empty string, and you say okay, good, okay, what the and then it say, hey, if I tell you, for example, this to string, okay, because what we're doing here is to coerce from an object to a string and then to a number, all right? But first to a string, and then now it give us this. So for example, we pass this with empty slots. It gives us now this. What in the F is this? You know, that's what we have to be careful when we want to coerce that string to that. So this is good for arrays. You know, what about objects? Okay, say to string, right? To string. Say, hey, got an expression. You can say, okay, let me do something here. Say object. All right, this is an empty object, and we say, hey, to string, right? And I want to coerce that to this. So it tells you now this famous object to object. So far so good. All right. So we are now understanding is what the toString is doing behind the scenes. So for primitive value, it behaves somewhat quite fairly intuitive, but for arrays, an object, it has this behavior. So far so good. Now, so the other is the toNumber. This is more interesting because it involves much more corner cases. So if you want to coerce that, right? Let's say you want to now transform in to a string into a number. If this is an empty, now let's gonna do this for this. So empty toNumber, or in this case, you have to wrap this like this. Say number. I mean, is this? Hey, I'm going to transform is empty as 0, and Boolean means that this is false. So if you pass now an empty string, it is false. But if you pass now a space, it becomes true. This is when now the parsing the empty string becomes a nightmare here. So for all of this string, it parses that to properly values, right? That's interesting because if you parse, for example, stuff like this, say 0.0, you know, into a number. Okay, I want to coerce that into a number. It do that this or this, so alright, it's okay, I get it. You don't deal with that. And if you pass non-valid numeric order or non-valid numeric number, so okay, give you NaN. And if you pass now an hexadecimal, it give you that. That's also interesting here that anytime it evaluates zeros or empty, it's going to coerce that into 9, which is to the actual value, which is great. That's interesting. It's actually doing some trailing. So for example, you do something like number and then do something white space 0.43 and some more white space, right? It actually take that number, which is great. All right. But for these bitwise operators, from the bitwise operator point of view, is something like this. So look at this. So if we now are here and then suddenly falls through null and undefined, right? And then suddenly, if we try to coerce this undefined value, it throws you not a number, what? And it throws you null, it throws you not 0, you know? Falls through nulls and undefined give you not a number, okay? And so far, the way how now it's coerced this is by calling the two primitive, and that two primitive abstract methods call now the two number, the value of first, and if it's not, into a string. But this is what happens when you're going to coerce now objects. So let's go with now numbers. They say, hey, what will be the number here? It's still this is a 0. You pass this, right? So if you pass now 1 through 3, which is good, it's now coercing that. But if you pass now an array, it gives you now not a number, okay? You know, it gives you now not a number. All right, it gives you now not a number. If you pass now an empty object, it gives you not a number. If you pass an empty array, it gives you 0. If you pass, well, not a number, valid, okay. If you pass now 3.53, a big int, it gives you that, like 10a, all right. If you pass now an array nested, it prints that out. If you pass now undefined, it gives you NaN. And if you pass now null, it gives you 0. And let's go into explore this a little bit.
So what about two numbers?
But later on, by looking at this, but by looking at this, okay. And this is what's going on here. Exactly. If you pass now a -0, it actually converts that into -0. Whether if you pass now a null or undefined, it gives you now 0. Is this true? I don't think so. Null or undefined. Null undefined, and it gives you that.
Is 2 string -0.
Of the rest.
Actually, this is remarkably consistent thing. It just becomes an empty string, which then just got not a representation of a number. So,
And this is with objects. Now it makes a lot of sense that it give you a not a number. That'll be all for this video. Take care. Bye bye.